Okay, Lady Ada, what is this?
Hey, everybody, and welcome to a summer night show and tell. It's what we do every Wednesday at 7:30 p.m. Me, Lady Ada, with me, Mr. Lady Ada. Here at the Adafruit factory, we do all the design, testing, manufacturing, shipping of electronics that you know and love. For the next half an hour, we're going to check in with people around the world in the Adafruit and Maker community. What are they building? What are they 3D printing? What are they sewing? What are they soldering? We're going to find out. I'll call on Noe+Pedro and then some other folks, and then maybe some people come by. We might get out of here early. So Noe+Pedro, why don't you unmute your mics and tell us what you're building?
Hello. So this week we put together a new neotrellis project. This is a soundboard, so you can hit some buttons and make it so. So there we go. It's using the Prop Maker Feather Wing and the Feather M4 Express. That makes it a lot easier because now we don't have to wire like a bunch of boards together. So it was really nice putting together. There's also an accelerometer on the Prop Maker. So we thought, well, what could we do with that? So when you shake it, it scrambles the audio. Yay! So it kind of shuffles it. And then we have this RGB LED that lets us know that it is indeed shuffled. And if we hit this button, not that button. Let me hit it again. All right, there we go. So it went green, and that means the arrangement has been reset. There's a lot more to it, so definitely check out the Learn Guide that we have. And I just love that sound. So I have a couple. I do have a problem. So I have a couple samples here, and I don't want to play them because
you're completely entertained by this. I could just
watch it. Okay, cool.
Excellent.
All right, so obviously you can put all sorts of different sounds on it. It's all written in Python.
Meme clips.
Meme clips, yeah, like a meme box, which was today's coupon code.
Yeah, so there's a bunch of kits that you put together, and we made sure that Content ID did not pick them. So we literally had Shazam right next to it. We were doing all the samples.
Can you guys tell what song this might be?
I've got a problem.
Not that one. Mark, stop saying that.
Oh, that's Thriller.
Maybe. We'll see if YouTube catches it or not.
Yeah, that's it.
Anyway, check out the video in the Learn Guide. It's really, really fun, and I had a lot of fun putting it together. So.
All right.
Okay, cool.
That was cool and fun to play.
We're catching up on our videos, so we have two videos from you this week. One is the
rainbow,
the rainbow printing, and then your latest one. So we'll have a double header tonight for those who want to watch lots of 3D printing.
Excellent. Thank you.
Okay.
And then for next week, we're going to do a video of that Falcon Heavy Rod launch. So we're going to be at the Kennedy Space Center on, I think, Saturday, Sunday, and Monday. So
this weekend,
if you guys are around the area, we're going to be giving out some pie badges.
Cocoa Beach.
Stop by for that.
All right, go see the Falcon Heavy. That sounds fun.
All right. First launch. Yay.
All right, next up,
Chris Young.
Chris Young, we got plenty of time for you. So
can you hear me?
Yes.
All right, let me switch over here. Published a new learning guide this week, and it's really a lead up to a learning guide I'm going to write where I'm finally going to document my ultimate remote. But it's such a big project that I thought I would do it in pieces. This is a screenshot from my ultimate remote, and you can see I've got some custom symbols on the second row there. This is how I control my cable TV box, my DVR. And you've got a previous channel, rewind, play, fast forward, pause, stop, next channel, and so on. And a bunch of arrow keys. Here's another screen. This is where I do my mouse control. That second row is all the directions that you can move the mouse. And the fourth row is like home, page up, and so on, page down. Here's another screen I implemented for a different assistive technology box. It's a complete keyboard. I've even got the function keys down there across the bottom of the screen. So all of these had to be made using custom fonts. You can convert any font using a font conversion tool that you've got in the Adafruit GFX package. But it really, finding all those different symbols and trying to convert them was just going to be too much of a hassle. So I actually drew out the bitmaps and wrote a little utility that displays them so you can see what you're doing. And I'll show you kind of how it works. Hang on a second here. Wake up. Mouse 8. 8, 9. Click. Go to sleep. This is a section of the code. I don't know if you can see on the left there. I've drawn out a little Bluetooth symbol.
Yeah.
Yeah.
Using just kind of ASCII text. Okay. And what you do is you draw that out kind of just using comments to see what it's going to look like. And then you can put together the bitmaps. The data is on the right there. You just look at what column I've put an X in, and then you convert that binary to a hex value and plug it all into a sketch, and it creates the custom bitmaps for you. And so that's how all of these various symbols that I just showed you were made, just by sketching out in a comment what bits were on and what bits were off. I scroll through here. You can see different ones, channel up, channel down. And so anyway, I just illustrated how to do that. The trick is you have to make everything 16 pixels wide so that the bitmaps come out on a complete word boundary. Or you could do 8 pixels wide and have them come out on an 8-bit boundary. But that's what makes it possible to sort of roll your own by hand, is by making sure that everything is an even multiple wide. And it works. So that's how I created my custom fonts for the Ultimate Remote. And my next job is to document everything else about it. Right now, Bill and I are working on designing a new case that's going to be a little bit more useful to people other than me. You know, it's one thing when you design something for yourself and you just kind of throw it together to meet your own needs, but then you say, I'm going to publish this. People don't want to see that junk that I threw together. You know, we want something nice and pretty, and hopefully a week or two, a couple of weeks maybe, we'll have something to share.
All right.
Oh, it looks great.
Thanks so much, Chris.
Look at that beautiful font, actually. I love it. You got the function keys, and like every icon is exactly what it is. Like the delete key looks just like the delete, the return, the page up. Like even looking at them, I'm like, oh, that's end and home. I can just immediately tell what they're supposed to be. So that's cool.
Yeah. All right. That's
nice
it,
work.
folks.
Thank you.
All right. Next up is Bill.
Hey, Bill.
Hey guys, how are you?
Hello. Good to see you.
Good to see you too. By the way, if you haven't seen it, so the remote that Chris is talking about, there's a video we made when I was out there where I walk through Chris's house and show everything that he controls with that little box with the remote. It's really kind of amazing. So I'm looking forward to his guide. That's not what I've been doing. So what I've been doing, let me make sure I can see myself here, is these, Lamore. I've been doing these.
They're cool looking. How did you do those? This is amazing. I have actually no idea.
Yeah. So I missed these. I really missed them. I was actually looking for them. I talked to Mike Burrell about when are we going to get some good pinout diagrams for the Pi Gamer. And he's like, oh, I don't have an artist to do it. And, you know, it's going to happen someday. And I'm like, well, I kind of do lots of Inkscape stuff for my day job. Would you like me to put it together for you? So I did. And so I can actually show you briefly what this is. It's, if you haven't seen it, these are the old, I don't know how you say the name, Pig Ape Check.
Pigianti. His name was Pigianti.
Yeah, he disappeared or something happened. And so that was that.
So, well, I'm not an artist, but I'm a good mimic, right? And I know the tools pretty well. And so I made diagrams. This one's for the M4 Express, and I actually have got a jump start on the Pi Gamer now as well. And then I got to do a lot of research and learn a lot about the SAMD chips, and then go back and forth with Lamore on what should actually be on these. So I'm really happy about these. I think we're really close to right on this one, right? We're about done.
That one was good. Yeah, I think that one's ready to go. I think one of the things that's also really nice is, you know, you're going to have the original files that we can edit. So that one of the challenges is people, they make beautiful pinout diagrams, and we love them and they're wonderful. But then there's always a typo, which is totally normal and it's not a big deal. You know, these chips are very confusing, and sometimes the data sheets are even wrong. But then we can't edit the files. So what I really like is that you're going to give us the original files so that we can go back and update them, because if you have a diagram and even one or two things are wrong, it's kind of almost not worth having it, which is really tragic because it uses more people than it helps.
Yeah, and I actually made a video, and I made it for you guys, and then we ended up sharing it publicly about how to make these and some tips that really they're not that hard if you set it up ahead of time and make a good grid. It's kind of like when you're in Eagle. If you set the grid up right, that's half the battle, right?
That's right.
It's the same kind of thing. So I made that for you guys.
Software. Maybe when you're done, if you or Chris want to actually write a guide on how to make those, I think that would be like the tool of the tool, because people are always asking us, how do you make these? And we said, well, we paid this fellow who's unfortunately, gone.
Yeah.
We can't contact him anymore.
I don't want the job of maintaining these for you.
No,
I'm happy to teach people to do it.
No, do a few and then put the files out and then the guide.
And then do it how to do it, because that, for example, we didn't used to have fritzing objects for everything, but then once we had a tool that Phil D made that made it easy to create fritzing objects, now we have one for every new product, and it makes a huge difference in getting people who are not engineers being able to draw out what they're building or what they want to build. Because it's like taking a photo, you can never take a good photo of electronics. The wires are too confusing. So I think this is like the next step. I think would be very helpful.
Yeah, good. Well, I'm glad you like it. I do have something else to show you. I hope I have a minute.
Yeah, sure. We have time.
All right, good. That never happens. So I have a couple other things. This one, actually, I got to give credit to Carter. Carter in the Discord, right?
Yeah.
Cotter. It looks like Cater, but it's Cotter. Carter.
Yeah.
So he actually made a library for the Nunchucky for Circuit Playground, and so this is actually I made a little 3D printed housing for it. That does back-to-back on the Trinket and makes a nice little adapter, right? And so this is running 100% Circuit Python, and this will let me put together a guide I need to for this. I may publish it with you. I may publish it on AT Makers, but one way or the other, this is one of the most requested things, because with the accelerometer, people who only have gross motor can actually drive their mouse. And then I have something really exciting that happened just yesterday, and that leads to this thing. And this thing is 100% wrong, but I love it. Okay. So
USB host insanity.
Yeah. So this is really kind of cool, and it's actually wired it up. It came out beautifully because everything's kind of tucked underneath.
Yeah.
But it turns out about a year ago, let me show you what I'm talking about here. About a year ago, we were working with Micah about remember these things, the IntelliKeys, right? And so we were working on getting the firmware updated and put the drivers out for Windows 10, and we made some progress on that. We got it out for Windows 10 and stuff like that, but it's still a mess. And it's really old code, and it's really we wouldn't do it that way again if we were starting today. And I was thinking about ways that we could support people on different platforms and stuff. And one of the ways was I was talking to Dan Halbert and said, do we have any chips that have 2 USB ports other than the TNC36, which is a little expensive and a little big and kind of overkill? And the answer was kind of no. And I went and I looked, and let me show you my screen. I was saying what I really want to do is I want to actually make a device. Sorry about the well, that's the only time it has ever shared the right screen. Okay. So I went looking for something where we could make kind of a filter that sits between the IntelliKeys and the other and the looking like a normal USB mouse. And it turns out that a developer named GD Sports, who I've never met, never had a conversation with until an email one this morning, actually found where we put the open source code online, went through, figured out the firmware from it, and made exactly what I was talking about making and decoded the entire protocol, which is just amazing, right?
All right.
Right? Open source wins. And so I reached out and we talked this afternoon, and basically they also have a device here, which is this host coprocessor, which is a teensy that just is a USB host that sends serial back, right? And so that's what I've got here. So we basically we decided that yes, it is completely possible to. Let me see if I can unshare this. Maybe, yeah, yep, okay. So is it possible to take 2 back-to-back trinkets, not teensies, trinkets, and wire them up so that one is the USB device, one is the USB host. They're communicating via UART between them. And can we make a filter that works? And it totally works. So it is not complete yet. I put 2 buttons on it just because I had the space. And I am super excited about this, because what this lets us do is it lets us write something that lets you put overlays that are custom into the Circuit Python side, which will be the device side will be in Circuit Python. You got a file system. You can load up the files. You can do all that kind of stuff. You got to keep them small because it's just a Trinket. And then on the other side is just an Arduino code that's just going to read that weird format and send it through over UART. I am really excited about this.
Yeah.
So, cool.
Yay. Yeah. So it's all cool stuff.
All right.
Nice.
Well, we're going to do a little bit of a show and tell. Scott's at a synth meetup where he's going to try not to buy a synth or something, which is like, it's an awesome thing.
Yeah, it's like a terrible idea.
But we're going to show something. But I actually have a story, Bill, that I think you'll appreciate. So since we've been doing stuff in the world of assistive technology in some way, it just changes the lens when we start new projects. So we're doing this machine learning stuff. You probably saw some of our funny videos. You say cat, and cat shows up. And
yep.
You say dog, and a picture of a dog shows up. And when we were doing this, and we looked at all the machine learning demos for hardware, which ain't great, and there's not a lot of them, and it's very early. There's certainly no one talking about anyone that has any accessibility needs working with machine learning. It is the last thing.
And why not, right? It's a natural, right?
To me, it's like, this is the reason to do it. Like, we're doing speech recognition.
Right.
It's the only thing you don't hear, no pun intended, is how this could help people who need assistive technology. So as we're designing this, we wanted to have it so, one, your machine learning device shows up as a USB drive, because we know how helpful that is for people who have to deploy these in the field. There's certain words that we spend 20 hours training the model so it can recognize them. So we wanted to have it so it's drag and drop. Then we said, well, everything should have a screen. So when you say the word, there should be some visual indicator that it recognizes the word, or it has a graphic. But what if you can't see? So now we're adding, if you say cat and it recognizes cat, it'll show the picture or show the word, and then it'll meow, or we'll say the word cat.
Right.
And then the other piece is the 3D printing that we're going to do for the buttons on our machine learning boards will either have a symbol, a letter, or Braille. So you don't even need to figure out which button it is. You can just feel which one it is, and you could use this machine learning device. Maybe you're going to say the word up because you want something to go up for you. If it works out, great. It'll have a picture of an arrow, and then after that, maybe it'll say the word up. That way, if something isn't working out, at least you knew it recognized it correctly before it's making a decision to move something in the buttons themselves. Right. Yeah, and so that I thought was neat, because our approach now is thinking about more people from the beginning, and I'm hoping that's contagious, because it's cool to have graphics and have machine learning stuff work and have visual indicators that things are working out, but I don't see that yet, and so that's why a lot of our devices now have all these multiple ways to interact with it. It just makes it a better product, but it also, the reason is because we just thought about others and assistive technology.
Yeah, it really does changes your perspective, and it helps everybody, right?
Yeah, and it's free. I mean, we already have this stuff on there, and it's funny because all these voice models are trained with thousands of people saying the same word, and you could listen to them. It's kind of funny. It's like cat, 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 cat. Why not use those as the auditory response that the device knows that it heard that word too? So
right.
Anyhow, okay. So cool. Yeah. So thanks for being on.
Watch it. You said you're going to play some of that today, right?
We'll have the video of it. Yeah, we have some of the machine learning stuff that we're going to show. And
I will tell you, if you're looking for something that I really think machine learning would be fantastic for, we lost something recently. We lost something called a scatter switch. It's an infrared switch. They used to be able to detect an intentional wink. So if I did that, it could tell when it was actually a switch.
Oh, okay.
And the difference between detecting a blink, which is just a quick both-sided thing, or an intentional wink, a switch that could do that would be huge.
Okay.
Yeah.
All right.
Yeah, there's things that, you could do very basic face recognition, but you could probably figure out a way to do eye recognition that's not blinking.
Right. Yep. Very cool.
All right, duly noted.
I have a question. Is it just the eye, or is it if they twitch their mouths or move their mouths up, or is it the eye?
what the scatter switch did was it's a it's an IR switch. What it really does is it shines a very bright infrared pattern, I believe, or at least LED on the skin, and it recognizes the change in the reflection is really all it used to do. But what it was primarily used for was either recognizing the movement of a cheek, like puffing out a cheek, or recognizing an intentional blink. I don't really want to, as an AT person, I don't want to put a really bright infrared LED next to somebody's eye. So I'm kind of looking for a different technology to solve the same problem, right?
I think a vision, that would be good for vision.
Yeah, and like the thing is, we don't want to do machine learning where it's like taking your photo and uploading it to the cloud. We just want non-network connected machine learning that's like, I mean, even if you had to tell someone like, hey, if you could put like a little triangle right here, instead of a bright light, it could just be like a little bit of makeup that just like, here's a little triangle that moves. Yep,
it's got to move differently when you blink, though, right? Because blink is a so that's interesting. By the way, Lamore, while I have you, I noticed the PDD pins were pulled out onto the feather wing. Is that intentional on the
What's PDD?
It's the camera interface for the CMD51.
Oh, the PCC pins?
Oh, PCCs. I'm sorry. Yeah, PCC.
Yeah. So what about them?
I just noticed that you actually had them all pulled out to the feather.
Yeah, I did. So that if people wanted to do camera projects, you would have all, because they did line up with pins that were useful.
Right.
Yes, you could connect a camera. We have a very, very basic camera example where you can just take an image from a camera and display it on a TFT.
I was very excited to see that. So.
It's something that we're thinking about, but we don't have any more than the example code we got right now.
But you get the tips when you spend this much time looking at the data sheets, right? And the schematics. You figure out what was going through Lamore's head.
Yeah.
Okay.
You, all right, so you have the roadmap now. All right. So we're gonna show. Lady is gonna talk about these OLEDs.
All right. So we've got new for Circuit Python. New for Circuit Python, we have OLED support. But it's built into Display I/O. So what's neat is that now you can have text when you do like serial prints. They print directly to the OLED. Here's it displaying with a feather, so it works under I2C and SPI. And you'll be able to do also fonts and bitmaps. It just looks like a normal Display I/O display. And of course, you get the console output. So it's just kind of cool. So we now have Display I/O for OLEDs and e-inks coming soon, but no ETA just yet.
Okay. Show all
these. Yeah, I showed them all.
Okay.
All right, thanks everybody.
Well, that is our show and tell tonight, everybody. Thanks so much for tuning in. We're here every single week, 7:30 p.m. Eastern time. We'll be here next week. Next week, we'll probably have a special guest, Pete Warden, in charge of TensorFlow on microcontrollers at Google. So that's a big.
That's a good time to ask.
Very timely.
You got things you want to ask for?
So come by. Pete will be here on the show and tell, and then Ask an Engineer. And special thanks to Noe+Pedro and Chris Young and Bill. We'll see everybody next week. Thanks so much for making this the best 24 minutes every single week.
Thanks, everybody. See you soon.
Bye, everybody.
Bye, folks.